Hey guys, Mr. Decker here. This is Unit 3, Lesson 11 on the draw loop. So we've been learning how to get sprites on the screen. We've been learning how to get text on the screen, get shapes on the screen, creating backgrounds, all that good stuff. We're now getting started with how to animate. Now the animations that we're creating with this, they're not going to be very complex, right? They're not going to be user controlled. They're going to be program controlled, and they're just going to kind of wiggle. But it's just getting us started on how to animate and how all this stuff works. So let's go over the computer science standards. There's a bunch of them for this lesson. Holy moly. All right. We're going to create clearly named variables that represent different data types and perform operations on their values. We're going to design and iteratively develop programs that combine control structures, including nested loops and compound conditionals. We're going to decompose problems and subproblems into parts to facilitate the design, implementation, and review of programs. We're going to incorporate existing code media and libraries into original programs and give attribution. We're going to systematically test and refine programs using a range of test cases. We're going to document programs in order to make them easier to follow, test, and debug. Okay. Essential question for today. How can we animate our images in GameLab? Well, we're going to learn how to animate images in GameLab, and it's pretty fun. It's pretty cool, and it's not as complicated as you think. This entire lesson is on code.org, so make sure you're signed in on code.org with your school Google account. Your grade for this lesson will be based on your programming in the lesson on code.org. Watching the video you're already watching right now is mandatory, so keep watching the video you're already watching right now. And you'll use this video to help you work your way through the lesson on code.org. There's no need to submit anything on this assignment page. All work for this assignment will be completed on code.org, where I will be checking on your progress and your programming. Okay, all right, so over to code.org. You should already know how to navigate, but just in case, we've got some people that made it all the way to lesson 11 without figuring out how to navigate on code.org. You might have to scroll down all the way to the bottom of your page here, but you just need to look for this button right here, CSD 2 7th grade. Click on Unit 3, Interactive Animations and Games. It'll take you to this page that we're about to get to right here, and it will show you all the stuff you've already done right here, and then you scroll down and you find the current lesson, which is right here, the draw loop. All right, bubble 1. Question of the day, we already went over. How can we animate our games how can we animate all right, how can we animate our images in GameLab? Well, we use the draw loop. That's really the nuts and bolts of it. We use the draw loop. This lesson introduces the draw loop, one of the core programming paradigms in GameLab. Students learn how to combine the draw loop with random numbers to manipulate some simple animations, first with dots and then with sprites. Let's continue. Bubble 2 and video.
Animated movies create the impression that characters are moving smoothly. But if you slow them down enough, you'll realize there are lots of individual images. Each image is just a little bit different from the one before. Speed them back up, and your eyes are tricked into thinking you're watching real-life motion. A very simple example of this effect is a flipbook. The key to animation, whether on paper or the computer, is that part of the drawing is changing over time. An easy way to achieve a change is to use the random number command to generate a new random location, size, or color for the shape we're drawing. Here's a simple program that draws a single rectangle with a random X position and a random Y position. If we run and reset this program over and over again, we can see that it draws the rectangle in a new position each time. But that's like a flipbook with only one page. To create real animations, we need to be able to string these pages of the flipbook together. In GameLab, we'll do this using the draw function. The draw function is special in GameLab. The commands inside of the draw function are run line by line from top to bottom. But once the computer reaches the end of the commands inside the draw function, it jumps back to the beginning and repeats the commands over and over again, as long as your program is running. Because the code in the draw function repeats in a loop, we'll just refer to this as the draw loop. Let's move our rectangle inside the draw loop and see what happens. Whoa, so many rectangles! We can see that a rectangle isn't just being drawn once anymore. GameLab is automatically calling the commands inside of the draw loop many times a second. In this program, that means that a new random X and Y location is generated, and then a rectangle is drawn over and over and over. You can place as many commands as you like inside of the draw function. For example, let's choose a new fill color before drawing each rectangle by placing a fill command inside the draw loop. Instead of always choosing the same color, we'll randomize by replacing the red value with the random number command. So in every frame of the flipbook, the computer is picking a new shade of red and setting that as the fill color. Then it picks a new X and Y value and draws a rectangle with those values. In a typical animated movie or flipbook, you don't continue to see all of the drawings that came earlier in the animation. Instead, you have the illusion of a single shape or character moving over time. You'll discover how to make that happen with the draw loop soon.
Boop, bleep, blop. All right, let's move forward. Bubble 3, the draw loop. Here's an example of the draw loop at work. Do this. Run the code and see how it works. Okay. Green circles appearing everywhere until eventually maybe they'll fill up the entire screen. Discuss with your partner, your partner's me right now, whether this looks like the flipbook you saw in the video. Why or why not? Well, I mean, it doesn't really look like the flipbook in the video because in the video we saw a guy walking around, and this one is circles filling up a screen. But let's learn about how this works. This is annoying me. Come on. Yes! Yes! It filled it up. All right, I'm going to run this again while I'm talking so that you can be distracted while I'm trying to teach you something. All right. So we've got no stroke going, which is why those ellipses don't have borders around them. They are the color sea green. Cool, got it. And then the draw loop is drawing these ellipses at random X and random Y positions between 0 and 400 for X and 0 and 400 for Y, which means that they're going to get drawn everywhere. Hey, it filled it up again. Awesome. And so that's why they're appearing at random all over the place. Now, the reason why it isn't drawing only one circle at random positions is because the background isn't also in the draw loop. See, watch this. Now that I have a background being drawn over and over and over again within the draw loop 30 times a second, that's something to remember. The frame rate for the draw loop is automatically set to 30 frames per second. Now you can go to world and eventually you will see a world or a frame rate block in here where you can adjust the frame rate. But for now, it's 30 times a second. So it's drawing circles 30 times a second. It's going to be drawing the background now 30 times a second. So check it. So see, now it's not filling up the screen with circles because it's also drawing a background 30 times a second. And then the computer on top of the background draws this random circle somewhere. So it's going voop, 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 over and over and over and over and over again. Over and over and over and over again, 30 times a second. Da, da, da. Bubble 4. Using the draw loop. Now it's your turn to do some work with the draw loop. Remember that the code inside the draw loop is run by GameLab over and over again. Do this. Add code to this program so that your drawing has orange circles being drawn too. Move on when your program looks like the picture on the right. So this is the same program we were running before, minus the background being drawn over and over again. But we need to have orange circles drawn too. So we need to grab a fill block, pop it right there inside the draw loop, orange, and then grab, let's see, ellipse. And then we want random numbers in here. So math drawer, we've got a random number block. Boop. And we're not worried about width and height right now. Random number block, 0 to 400, 0 to 400. Run it. There you go. Now we've got green and orange ones. Do we have the frame rate block yet? Nope. Okay. So now we're imitating this picture up here. And if you missed that, so drawing, ellipse, boom. I'm not worried about the width and height. So I can hit that arrow twice. Now I've just got X and Y here. And I am going to go to the math drawer, random number, 0, 400, 0, 400, reset, run, and that's how we did it. Finish, continue. All right. This program has one small difference that will make it run a little differently. Again, though, remember, all your code outside the draw loop is run first one time. All your code inside the draw loop is run over and over forever. So what will this program do? Write your prediction below. So let's see, we've got, okay, so here's the introduction of the frame rate block. I really love the frame rate block. I like to use the frame rate block. The frame rate block slows down or speeds up the number of times the draw loop is drawing per second. So in this case, it's going to be drawing 5 times per second. If you did not use the frame rate block at all, it draws it 30 times a second. So this is slowing it down significantly. No stroke, that means that there's not going to be a border drawn around anything. The background is drawn blue one time, and then fill yellow here one time. So, and then here's the draw loop. Remember, this is drawn 30 times a second. This is only drawn once right here between lines 3 and 5. So in the draw loop, we have a background red. Interesting. So that means that while a blue background gets drawn first, very quickly as the computer reads it, it's going to be drawing a red background over and over and over again, 5 times a second. And it's going to be making a circle, which will be at a random X and random Y position 5 times a second. So, and that circle, since fill yellow is right here, is probably going to be a yellow circle. So let's type this in. It's the frame rate is going to slow down to 5 times per second. The background will not be blue because the draw loop will draw the background in the color red over and over again on top of that blue background, and then a yellow ellipse will appear at random X and Y values between 0 and 400 repeatedly. Boom. Run it. And yeah, that's exactly what's happening. So did you even see a blue background? Blue, no. Blue, no. Blue, no. Just red. It draws it so fast that you can't even see it blue ever. So this is useless code right here on line 4. You are useless. You are useless. All right, finish. Continue. Level 6. Sprites in the draw loop. By changing sprite properties in the draw loop, you can animate your characters. Do this. Run the code to see how it works. Okay. He's a little alien that's like nervous about meeting the humans. Poor little guy. I understand your anxiety, bro. I have anxiety too. Okay. Discuss with your partner why some of the code is inside the draw loop and some code is outside the draw loop. Well, I can tell you. All right. Inside the draw loop, it's everything you want to appear on the screen, right? And correctly. So inside the draw loop, we're drawing the background over and over and over and over and over again, 30 times a second. we are making our sprite rotate between -10 and 10 degrees. So that's what's making him wiggle or shake with anxiety. And then on line 6 in the code, also within the draw loop, we have draw sprites, which is making sure that the sprite is drawn on top of that background that's also being drawn 30 times a second. So it's drawing this, it's doing this in order still, shoop, 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 30 times a second. So first it's drawing the background, then it's making sure that the sprite is rotating between -10 and 10 degrees, and then it's drawing the sprite 30 times a second. Right, the computer is reading the draw loop 30 times a second, doing it over and over and over again. The reason why the variable and set animation is not in the draw loop is because it doesn't need to be. You only need to set up a variable one time. Try to change the numbers in the random number block. Okay, let's go big or go home, right? So -70, 70, and see how bad his anxiety gets. Oh yeah, he's like, he can't even contain it now. He's just like, he's going to puke at some point because he can't handle it. All right, finish. Continue. Bubble 7. On bubble 7, we're updating properties. This animation already is updating one sprite's X property to make it look like it's shaking. Okay, let's run the program to see how it works. So our pencil is wiggling, but the paintbrush is not. So we got to get the paintbrush to wiggle like it's doing over here in the sample image up there. So let's edit the code in this program to make the second sprite shake like the first one, and then we'll move on when our program looks like the picture on the right here. All right, so we are setting up our variables here for our animations that are on our animation tab over here, and then into the code. We're going to look at, and then they're setting them up correctly, right, using the correct animation name. Oh no, I clicked the wrong button. You guys, I'm sorry, I apologize. All right. So I'm going to squeeze, there we go. All right, in the draw loop, we've got background being drawn white. We've got the pencil's X value being a random number between 100 and 110. So that's on this left or right plane. X is left or right. Y is up and down. The grid, if you need it. And then the brush's X value is just stagnant at 300. It's just hanging out over here. So we need to go to the math drawer, random number block. And since it's over here, we'll do like 300 to 310. How about it? And then it should wiggle back and forth just like the pencil is. Yeah. Very good. Finish. Continue. All right. Let's go through A, B, C, and D. Updating rotation. Make both aliens dance in space using their rotation properties. We can do this. Let's make the aliens dance in space. This level combines some of the skills you've already seen. It's drawing ellipses in the background and also updating sprite properties. This time it's changing the sprite.rotation property. Do this. This animation already is updating one sprite's rotation property to make it look like it's shaking. Run the program to see how it works. Okay. So this guy over here is shaking. This guy doesn't have the wiggles. I like how these stars are blinking in and out all over the place. I like that. Add code to this program to make the other alien shake just like the first one. All right, so we need to find the draw loop down here on line 17. And we can see how the green alien is using the dot rotation, gets random number. Here's random number. Sprite.rotation. It looks like this in the toolbox, but when you put it down out here, it looks a little different. It adds that purple to it. So pink alien using camel case. I don't think I need to show you any more pictures of camels. I'm pretty sure you figured that out by now. And for this one, right, we'll just match it. -5, 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. 5. Because with rotation, we're not talking about X and Y position. We're talking about rotation. We're talking about degrees. So now they're both wiggling around. Frame rate set to 10. Let's change the frame rate. Let's have some fun. To 50. 50 times a second. Now they're like really shaking really fast. And then I can play with the amount that they are rotating. So let's mess with that. Let's do 20 by 20. Let's see, negative 50. Whoop, 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 whoop. Negative 50, 50. There we go. Now you can see the difference there. And if we slow the frame rate down, 5, right? If we change the frame rate to 15, so you're getting the idea, right? Messing with the frame rate, messing with degrees, messing with the random number block, changing the rotation, putting it all in the draw loop. The draw loop has the computer, the computer is reading the draw loop at a rate of 30 times per second, or it's reading it at the frame rate that you tell it to, right? All depending. Debug the blurry sprite. We can do that. Debug the blurry sprite. What I expected it to do is to shake around. What it is doing instead is some blurry shaking. So let's run it. Oh, yeah, okay. So what's happening here? What's the problemo? Run the program to see the bug. Use the clues to try to find the bug. Once you found it, fix the program so it looks like the image on the right. So, okay, I instantly see it, but my eyes are trained with programs. I know what I'm looking at and all that good stuff, but you guys might not. So let's break this down. So inside the draw loop, we're setting up our variable and setting up the animation, or setting the variable to the specific sprite over here on the animation tab, rather. The background is being drawn as light yellow over and over and over again. And then Blender's X position gets 200 plus random number -5, 5. So that means that doing the simple math here, it's a random number between 195 and 205. And its Y position is doing the same thing. Blender's Y position gets 200 plus random number -5, 5. So that means that, again, 200 minus 5 is, or 200 plus -5 is 195. 200 plus 5 is 205, right? So 195, 205. The 200 plus is kind of necessary because you could just put in 195 and 205 in the random number block without using the enumerator there. And then drawing the sprites in there. The reason why it's messed up is because of this. So if we take that out of the draw loop where it doesn't belong, right, now it's doing what it's supposed to. It's drawing the background over and over and over again, and then drawing the sprite on top of it. And when it draws the sprite on top of it, it's using these X gets and Y gets blocks to influence its position at these random numbers at 200 plus. Finish. Continue. Well, yeah, I guess it's kind of bubble C, right? Debug repeated animations. This bubbly sprite should have multiple frames of animation that repeat, but it seems to stop almost immediately. What I expected it to do is that the sprite should animate smoothly. What it's doing instead is the sprite has after image and stops animating. Who writes this stuff? All right. The sprite stops animating is all it needs to say there. Do this. Run the program to see the bug. Okay. Oh, okay, yeah. You can see it starts to draw it and then it stops. All right. Use the clues to find the bug. All right, so we've got our sprite being set up here outside the draw loop, which is where we want it to be. And then inside the draw loop, draw sprites. What else needs to be in there? Let's find a clue. Blue's clues. All right, some levels in GameLab will let you use multi-frame animations with your sprites, which makes them seem like they're moving. Whenever you use these animations, make sure to add a background block at the start of your draw loop. Otherwise, it will look like the sprite isn't moving. Again, who is writing this stuff? I'm going to write a strongly worded letter to them. The sprite isn't moving since all of the frames will draw on top of each other. And you know what? My strongly worded letter that I write to code.org is going to be grammatically correct, because that's how I roll. Because if I'm complaining about grammar, I better be grammatically correct. Okay, run. There we go. And it's a kind of cool animation. And this animation is working probably because they multi-framed it over on the animation tab. And Mr. Decker was right. All right. They multi-framed it. So in frame 1, it looks like that. In frame 2, it looks like that. In frame 3, it looks like that. In frame 4, it looks like that. And just like the young lady explained to us back on the video a while ago on Bubble 2, we learned that the eye gets tricked into seeing a smooth animation while it's really only 4 frames, right? But because those frames are being drawn so quickly, our eyes are just like, wow, so neat. When if our eyes could pick up frames faster, then we would see it like all weird looking. But instead, we see a smooth animation because our eyes are kind of slow eyes. All right, debug. Debug sprite not moving. Debug why the sprite is not moving even though we update its position in the draw loop. Okay. What I expected it to do was to shake around. What it's doing instead is not moving around at all. Do this. Run the program to see the bug. Yeah, that blender is just sitting there, not doing anything. Use the clues to try to find the bug. All right. Well, let's see. Inside the draw loop should be the background. What happens? The blender disappeared. What happened to the blender? Well, the draw sprites is up here, so that means that it drew the sprite once, but it got to the draw loop so fast that our eyes are too slow to see the blender. So where did the draw sprites block need to be? Inside the draw loop, Mr. Decker. You kids are so smart. All right, there you go. So now it's drawing the background over and over again 30 times a second because we haven't adjusted the frame rate. And it's wiggling it around, messing with its X property and its Y property, and drawing the sprite on top of the background. That's important because if we put the draw sprites right there, what happens? It's drawing the background on top of the sprite. If we put the sprite down here, it's drawing the sprite on top of the background. The kids understand. All right, we've done A, B, C, and D. Let's finish. Moving on to bubble 9. Salt shaker. All right, this level is very similar to the last, but this time you'll add in the draw loop yourself. Do this. This guy's putting a lot of salt on his french fries. I'm just imagining there's some french fries down here because yum french fries. All right, do this. Add the draw loop block at the bottom of this program. Okay, added. Move any blocks that need to be inside the draw loop. Well, we know the background needs to be there. We know that draw sprites needs to be there. Run it. Okay, so now we got a salt shaker, but it's not moving. We need it to move like this salt shaker, because if you just turn it upside down, there might be a little bit of moisture around the holes in the top of the salt shaker and nothing's coming out. So let's make some salt come out of the salt shaker. Let's shake the salt shaker, because that's really the life goal of any salt shaker. If a salt shaker were to tell you what they wanted to do with their life, they would say, well, they want to be turned upside down and shake, buddy. Okay, so let's make that happen. A dream come true, buddy. Let's make it happen. So we need to go to the sprite drawer, we're going to grab sprite.y because we're moving it. Whoop, we're going to put that right there. We're moving it up and down. Remember, y up and down, x left and right. So we need to match the variable salt, salt, salt. And salt.y gets random number. And since it's right at 200, we'll do like 195 to 205. And let's do it. Yeah. So now we're getting salt out of the salt shaker. It's living the dream of every salt shaker on the planet, living out its purpose. All right, finish, continue. All right, let's go to the challenge, extend your scene. You can do free play if you want, not required, but the extend your scene is definitely required. We're going to be taking a look back at our scenes that we made in the last lesson where what did you do in the last lesson? You did your mini project where you made your caption scenes with the text and 2 sprites and background and a shape and all that good stuff. And I did the Happy Halloween thing. Okay, this is the sprite scene you made in the last lesson. You'll now be updating it a little bit to use the draw loop and sprite properties. Do this. Add a draw loop to your program. You should only have one draw loop. Use the lasso selector, click, hold, and drag to select the code that will be updated each time and place it in your draw loop. The lasso selector, they're just talking about, remember I've showed you how to like copy Control-C, Control-V stuff and move it around. But when you do that Control-C, Control-V thing, you'll have to delete the old stuff, so you can lasso select it and backspace it and it goes away, but I'll Control Z that, which is my undo button, because I want that to be there. And let's talk about the code that I've put in here to set this up right here. So obviously you're going to be handling your own scene. My scene is my scene, your scene is your scene. All's good in the hood. So the first thing I did, and I put comment blocks in here just so your eyes can look at it and make sense of it. So slowing down the frame rate right here down to 2, right? So 2 times per second, things are changing. I set up my sprites with the variables and the set animation to my animations that I so expertly drew over here, right? I didn't change much. Eyebrows, mouths, yeah. So that's why they're ghost mouth and ghost brows. You remember. All right. And then inside my draw loop is everything I want to show up on the screen. So my background, my moon right here, my text, and then filament cream for my stars that are twinkling in and out all over the place. And then you can see the code that makes the twinkling stars. There's a lot of it. And then my draw sprites block down here, of course. Inside the draw loop, that's the last thing I put down. Inside the draw loop. And then right here, to animate my sprites, I influence the X and Y properties or parameters. .x gets random number 105, 115, ghost mouth. Y gets ghost brows X, and it's just a matter of making my ghosts kind of look like they're floating around a little bit, right? Obviously, you can see the frames. It's like it's lagging. If I speed that up to 30 frames per second, like it would be normally, it looks like this, and it's kind of a lot to take in, you know. So that's why I changed it to 2. But you can play around with that for yours with the frame rate and see what you get. If you don't remember where to find the frame rate, it's in the world drawer. Your drawing drawer contains all of these good things: text, fill, stroke, no stroke, background color, rectangles, ellipses, so on and so forth. You can even put lines in here. Variables, if you want to throw a variable in here, but it's not required for this. You have variables already. You know, your world frame rate is a variable. Your variable ghost mouth variable, or your sprite variables are variables. And they're found in the sprite drawer. And then setting your animation, influencing X or Y, right? You've got to pull that out here. Whoa, that put that in a weird spot. Control Z to undo. You can mess with the scale. You can mess with rotation if you want them to rotate back and forth. Shake, wiggle, rock and roll, right? And then in your math drawer, you have the random number block. And then in every, well, not every drawer, but in some of the drawers, you have the comment block. It's in every drawer except the variable drawer, apparently. All right. And that's it, right? So I hope you enjoyed this lesson. I know that I did. This one was actually pretty fun because I love animation. I like cartoons, bro. I'm a 35-year-old man watching cartoons. It's okay. It's how I live my life. I'm an adult. I can make choices like that. All right. Love you guys. Hope you enjoyed it. Hope you understand it. If you have any questions, remember you can always pop into my Google Meets. You can always send me an email. You can always send me a Canvas message. Later.